So this is 20 centimeters, 0 and 4.5 centimeter. So the distance between this is 20. So this 20. Distance between. All right. So from the normal story now, we know what to do. Upper minus lower, 20 minus 0, 4.5 minus 0, 100 minus lower, then theta minus 0, 20 minus 0, 20, 4.5, 100 over theta cross multiply, 20 theta, 450. Divide both sides by 20, so 22.5 degrees Celsius. All right, so let's start heat. Heat and its measurement. Heat is defined as the total internal energy present in a body. Next line. The only form of heat energy is thermal energy. THERMAL, thermal energy. Next line. The heat of a body can be measured using calorimeter. The heat of a body can be measured using calorimeter. Calorimeter. Calorimeter, yes. We use thermometer for temperature, calorimeter for heat. In brackets, the commonly used calorimeter, in brackets, just write that statement. The commonly used calorimeter is bomb calorimeter, bomb calorimeter. Bomb calorimeter. Close the brackets. For the sake of knowledge, that's the commonly used calorimeter. Call it bomb calorimeter. Okay. Next line. The standard units of heat energy. The standard unit of heat energy is joules. 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 That's the SI unit for heat absorbed by a body or lost by a body. The standard unit is joules. Standard unit is joules. Next line. The quantity of heat absorbed. The quantity of heat absorbed or lost by a body. The quantity of heat absorbed or lost by a body is dependent on three factors. The quantity of heat absorbed or lost by a body is dependent on three factors, which are: number one, mass of the body. Mass of the body. The symbol of mass is M in kilogram, kg. Write that way, sir. Mass of the body, M for the symbol of mass, will be using kg, the unit of mass. Number two factor, specific heat capacity. Specific heat capacity. Small letter C, that's the symbol, in joules per kilogram per Kelvin. Joules per kilogram per Kelvin. Then the number three factor is temperature change. Temperature change. Delta theta in Kelvin or degree Celsius. So these are the three factors that the quantity of heat absorbed or lost by a body is dependent on. All right. If you remember carefully in my class, I have told us that the factors to which a particular object or a particular quantity depends on makes the formula for that particular quantity. So now the quantity we are talking about now is heat. Now the amount of heat absorbed or the amount of heat lost depends on these factors. So in other words, we can say that the formula for the quantity of heat is the product of these factors. Now let's write it down. Mathematically, comma, the quantity of heat absorbed or released by a body. The quantity of heat absorbed or released by a body is the product of these factors. Is the product of these factors. These, plural. The quantity of heat absorbed or released by a body is the product of these factors. That is, we can say heat absorbed / released is equal to mass times specific heat capacity times change in temperature. So by symbol, we can say capital H is equals to MC change in theta. M for the mass, C for specific heat capacity like I've defined, then change in temperature for the temperature difference. We call this equation 1. So we have gotten the formula for heat energy in relation to the factors that affect the quantity of heat absorbed or released by a body. MC change in theta. Next thing is to define this second factor. Let's define it, because every materials have their respective specific heat capacity. So let's define specific heat capacity. Specific heat capacity. Specific heat capacity. Small letter C in brackets. Small letter C, mind you, not capital letter. Please write the way I'm writing. I've made it a subtopic, especially for the WAEC students. In fact, everybody, because we need to know definition. We need to know definition of terms. We need to know some of the principles governing each definition. So let's write specific capacity. This can be defined as the quantity of heat. This can be defined as the quantity of heat. This can be defined as the quantity of heat needed to raise. Quantity of heat needed to raise. RAISE. Quantity of heat needed to raise a unit mass. A unit mass. Unit mass. Open a bracket, 1 kg. Typing of units. 1 kg, 1 kilogram. Needed to raise a unit mass of a body. A unit mass of a body through a unit rise. Through a unit rise in temperature. Through a unit rise in temperature. Open a bracket, 1 degree Celsius or 1 Kelvin. Full stop. I've told us time without number. Formula is the definition in physics. Definition is the formula. If you are asked for the formula now for specific heat capacity, see the definition. We said specific heat capacity is defined as the quantity of heat. Look at the statement. Quantity of heat needed to raise a unit mass per unit mass. Unit mass per unit temperature. Unit mass, unit temperature. Quantity of heat needed to raise unit mass of a body through a unit. 1 means per unit. So by symbol, specific heat capacity is small letter C. Quantity of heat is capital letter H. Mass is our small letter M, then change in temperature. Equation 2. ask your question. Just like making C the subject of formula. That is what it has become. From your formula for H, make C the subject. You are dividing through by M, change in theta. So specific capacity is the quantity of heat, H, needed to raise a unit mass of that object per unit rise in temperature. And that was how we got the units. Joules per kilogram per Kelvin. Joules for the heat divided by kilogram mass divided by Kelvin for temperature. So that's the unit for specific capacity. All right. So let's write some quantities and their specific heat capacity, some objects. There are some materials, we just need to know them. For the sake of constants. So let's see, I only mentioned two. Specific capacity of water, C water, is constant, which is 4,200 joules per kilogram per Kelvin. Then specific capacity for copper is 330 joules per kilogram per Kelvin. It's a range though. Copper can be 330 to 350. It's a range. So there are some materials that the specific capacity needs to be known, but they will give us in brackets, especially for the wired students, to be given in brackets. Even JAM, over time, JAM has given us the questions in the past years. They would always give the specific capacity of the object in brackets. So always check that bracket. Scroll down to check your question well. You know the system we are using. Some information may still be down. So scroll down until you enter number 3. You know, okay, that's the end of that question. You understand what I'm saying? Yes. You scroll down. You scroll down from the mouse, using the mouse, or you use your control on your keyboard. The arrow pointing down is to scroll down. Arrow pointing up is to scroll up. Arrow sideways, left or right. At least to know the question number you have answered. The one you answered will turn green. The one you are yet to answer will be red. Those that have done JAM before can attest to what I'm saying. All right, so they will give us in bracket. I'm very certain, by God's grace, I'm certain. All right, so let's see the next subheading. There's another material, there's another parameter, we call it heat capacity. It's different from specific heat capacity. Open the bracket, so it's capital letter CP. Heat capacity. Na me she dey talk about. Ọ̀rọ̀ yẹn ká mi lára o. Jẹ́ n bẹ́sẹ̀ mi sọ̀rọ̀. Make I go.